Hi, I'm Michael Rees. I'm a Principal Program Manager in the Big Data team responsible for SQL. It is my pleasure today to give you an introduction to SQL for the C# developer. The first question that we are asking ourselves is why SQL? There are already a lot of big data processing languages out there, and SQL is the new processing language for big data that we are shipping as part of the Azure Data Lake offering in the Azure Data Lake Analytics Job Service. So why a new query language? Why don't we use the existing SQL dialects or use one of the existing programming language-based approaches? Well, let me take a look at some of the characteristics of big data analytics use cases and kind of look at those and then use those to assess the current languages as well as motivate why we need a new language. So if you look at the use cases that you have for big data analytics, such as botnet analysis in a digital crime unit where you analyze web logs with complex algorithms or do feature extractions and classification for doing image processing. Even if you do shopping basket analysis to do shopping recommendations using algorithms. All these use cases are big data analytics and data preparation use cases that all have kind of the same requirements. They require to be able to process any type of data, be it structured, be it unstructured. They need specific proprietary custom algorithms that allow them to analyze the data in a deep domain-specific sense. And they need to be able to scale that processing over any size and be efficient at doing so. So if you take these requirements and look at the existing languages that exist in the ecosystem today, you will notice that there might be a need for a new language. So if you look at SQL languages for big data, such as different varieties of SQL and Hive, etc., they are really good at providing you an abstraction that makes the system care about the parallelization and scaling, and you as a programmer don't. On the other hand, the extensibility of adding your own user code is very hard, and it's also hard to work with data that is not necessarily fully structured. Yes, you can do structure on read, but you still have to create metadata objects, which in an enterprise environment often then takes away the flexibility from the programmer and moves it into the hands of a database administrator. If you look at the programming languages for big data, such as MapReduce, CodeFlow, or things like Spark, it's very extensible because, yes, you have your whole user code available, and so therefore the extensibility is native. However, declarativity is bolted on and not native. Often, users have to care about scale and performance, have to manage the scale-out topologies themselves, know how to shuffle and how to deal with parallelism, etc. And even on those languages that add an additional level of abstraction, such as an embedded SQL, SQL then often is second class within a string, so you don't have really the tool support. And often also you don't have really a system that gives you code reuse and sharing across queries because it's code and not a script that you're submitting. So we think that SQL is giving us the benefit of both by giving us the declarativity of SQL combined with the extensibility of a programming language and offer that in an equally native experience in the language. So besides getting the benefit of both, it also makes it easy for you by unifying, that's where the U in SQL is coming from, unstructured and structured data processing, declarative SQL and custom imperative code, local queries in your local system, as well as remote queries into other data sources, such as the SQL database. And therefore, it increases the productivity and agility from day one and at day 100 for you. So SQL, however, is not a completely new language that we devised just in the last couple of months. SQL actually has a long history of background languages on which we base the language. It starts out with Scope, which is our Microsoft internal big data language that is giving us the SQL and C# integration model and the optimization and scaling framework in which we execute both Scope and SQL. Today, right now, Scope is running hundreds of thousands of jobs each day within Microsoft that runs basically the Microsoft business in Bing, Xbox, Office 365, and a lot of other teams inside Microsoft. In addition, we also, of course, looked at the long history that both we and the community has around SQL, both in its guise as T-SQL and SQL Server, as well as the ANSI SQL standard. And we have integrated many of the SQL capabilities into USQL, such as windowing functions, the metadata model, etc., etc., etc. So let's focus today in this presentation on the USQL extensibility model. So specifically, how is USQL integrated with the imperative aspects of C# and show you how you can extend your USQL query language with C# expressions. In particularly, we have 3 user-defined extension points, as well as the native integration of C# using C# expressions in select expressions. Today we will be focusing on the C# expressions and the user-defined functions. We can also cover user-defined operators and user-defined aggregates in some of the resources that you will find at the end of the presentation. So now let's go and actually take a look at USQL. So let me show you how to use USQL to do some quick data preparation and analytics on some Twitter data that I loaded into my Azure Data Lake account. So what you see here is Visual Studio. And in Visual Studio, we have installed the Azure Data Lake tools extension, which gives me this data lake integration and ability to write USQL scripts from within Visual Studio. I also have down here my set of comma-separated value files that contain tweet data of me and some of my colleagues and friends that contain both the tweets as well as all the tweets that mention me or retweet me. So now let's take a look at one of those files. So I just basically open up the file using a stream previewer here. And as you can see, the file contains basically 4 columns: a date, a time, the name of the Twitter handle of the person tweeting, plus the tweet itself that may contain mentions and references to other people as well. So now let's do some analytics and data prep for later so that somebody can do some more in-depth social analytics or something on my tweets. So for that, I open a new project. And in particular, I choose a new project that has a USQL template. And there are a couple of different templates. I'm going to go with the USQL project template. That is the actual place where I write my USQL scripts. So let's open this. And this now has opened a USQL solution over here. And the USQL solution contains basically a USQL file that is script.usql. And behind it, there is a .cs file, which is allowing us to basically put code behind C# code that gets deployed together with the script to run my queries. So I'm also having a submit button up here, plus my USQL account name and my default database and default schema, although that's not relevant at the moment because I'm only operating on files. So let's start and write my first USQL script. The first step in a USQL script is that I need to extract a schema from the files that I want to operate on. So we saw it was a tab delimited file or CSV file. So let's add the date of type string. And as you can see, as I type, Visual Studio gives me IntelliSense for my USQL language. And it offers me, like the built-in C# types, as the ability to schematize my data. So I say date, time string, author string, and my tweet. Now I do that from a location. And I need to extract that using a so-called extractor. And there is already a built-in extractor for CSV that I'm just referring to here. Now, of course, I need to be able to extract this from a file. So I go back to my File Explorer, right-click, get my path name here, and insert it into the location. Now, I don't want to do that for just one file. I want to do that for all the files inside the directory. So I can put in here a C#-like pattern that allows me to basically extend the path over all the files inside that directory. So that's the first thing. The second thing now, of course, is I do some processing on it. I will get to that in a minute. And at the end, I will have to write the result back into a file because we are in a batch service here. So I say output at t to, and let's just say samples output tweet analysis.csv and use the default built-in outputters for CSV data. So this is actually already a valid uSQL script. It doesn't do much, it just copies all the files, concatenates them into a single file here. So let's now do some more interesting analytics on it. So one thing that the tweets contain is mentions. So let me write some uSQL script that basically gets me the count for all the authors, plus also the counts for all the mentions into my result. So what I do here is I say first I extract all my mentions, so I call this expression an add m, and now I start doing a select statement over the row set. So I say select from at t, and then I will have to tell you what I'm selecting here. So obviously what I do is I say tweet dot, and as you can see, IntelliSense is giving me access to all the C# functions that I have on a string data type. In this case, I want to first split it into words. So I say split with a white space. And now I only want to have the mentions. Mentions are all these words that start with an @ sign. So I now put a link where here with a lambda expression that basically just checks that I'm starting with the @ sign. And now this is a column, so I have to give this a name. Let's say m for mention as well. And I have to wrap this into a type that uSQL understands in terms of array. So we have a built-in SQL array string type, and off I go. Now this m is only the mentions. I need more. I need this resulting t, which is not the original t. So now I have to kind of do some union here. So what I want to do is I want to actually pivot my arrays into individual row. So I do this by refining my m to be a new m that is defined as the following query, which is basically author from the old m. Now cross-apply is a SQL statement that applies the next expression, explode, to each of the rows in my incoming row set. And basically explode now pivots an array into a row per item inside the array. So the input there was called m, so I say explode m, and now I give this name as well, t for table or whatever, and author was the value that I had. And now I union this in my next statement again into my t, into an interesting union. Let's say select, and I take author from my original t. I union this with select author from my m's. And now I basically have them put together, but I actually want to preserve which type of author they are. So I'm going to add a category here. So I say the first one are author as category. And the second type of author is a mention, oops, typing it correctly, as category. Now this gives me a union between these two, and now I can do an interesting group by, for example. So that's my resulting T here. And what I do here is I do a select, author, and category. And maybe if I add my @t down here, I'm actually going to get IntelliSense up here as well. I can say count star as tweet count from T. Now I need a group by here, so I say group by author comma, category. And voila, I now have basically already done a simple analysis here inside my script. There's a squiggly mark here because I need to use the uppercase as, not the lowercase, which is a typecast. And now let's just add an order by on my output here so I can look at it, tweet count, descending. And basically, I have my first cut at it. You will notice up here, I very easily integrated my C# expression into my code without a lot of wrapping or whatever. It just naturally flows into the language. I show you in a minute how you can do that with user code as well, with using the code behind. And now I can go and submit this thing inside this script inside my Azure Data Lake, and it will be executing. It will be showing me here a nice job interaction. It shows me how it prepares, queues, runs, and finalizes the job. And it shows me job graphs, etc. While it's running, let me go back to the script and just show you how I can now do some refactorization of my code. Let's assume I don't really like to have a lot of C# code floating in my script because it doesn't really tell me at one glance what it's doing. So what I do is I actually use my code behind capabilities to wrap that into a C# function and basically deploy it together and manage it separately in my CS file. So I copy this script here and I go over to my code behind file. In my code behind file, you notice there is a already pre-populated namespace. So I'm going to add system.link because I'm going to use the where clause. And let's call this, instead of uSQL application 1, let's call this tweet analysis. And then I'm adding, obviously, a public class. And let's call the class UDFs for user-defined functions. And then in here, I have a static public function. Let's call this get, returning a string, actually an array of strings. So it's SQL array of string get mentions. It takes a string called tweet. And now it returns something. And what does it return? Well, it actually returns this expression here. Now this one here I have to fix up because this is my uSQL type name. I need the SQL type, the C# type name here. And actually now I have my function here, get mentions, inside this namespace and class. So I just can go back here and replace all of this with a reference to my namespace. So that's tweet analysis dot UDFs dot get mentions of tweet. And off we go. Now this is exactly the same. I can submit this script as well. As you can see, while the query is executing, once it's running, you will see the job graph of the actual execution tree appearing within the job graph window over here. The green boxes are work units that have been completed already, and the blue ones are the ones that are running. And you see up here the indication of the input, which is these 7 files that I had, which are CSV files. And down here, it shows us the output that it will be producing. While the script is running, I can show you which script actually got submitted to the service. So if I click the script button down below, it is opening me the script. And if you look at the script, you will notice that because I have this code behind file, it actually does register an assembly for me on my behalf. And it references the assembly so that the code inside that code behind file actually becomes available within my uSQL script here. And then at the end, of course, it does do a footer in which it actually drops the automatically generated assembly as well. Now this actually means I can do that myself. So in order to do that myself, for example, if I want to share the assembly with other people or want to have it available up in my uSQL metadata store, I can go to my solution over here. I can add a new project, and this new project now is a class library for uSQL application. So I'm adding this, and now what I do is I go up here inside my script. I basically say copy, go down to my class inside my C# project and paste that over. Then I can go here and say register assembly. And let's assume I registered it inside my account, inside the master database. I use the assembly name, let's say tweet analysis. I submit this job, so this job will now go and register the assembly. I now go back to my script over here. The only thing I now have to do is I have to say at the beginning of my script, reference assembly tweet analysis, since we are inside the master database context. And I go and delete the code behind file because I don't need that anymore. And now I can submit this job once the assembly has been registered, and I will get exactly the same behavior, except for now everybody can use my code that I have written and shared with my users inside the database. So as you can see, it was very easy to combine the expressive power and abstraction of parallelization using SQL while extending it with all the capabilities that you have with a procedural language like C# to do custom code and to do your own processing specific to the data that you are going to analyze. So now that you have seen how easy it is to extend uSQL with user code, let me just mention some additional interesting features that uSQL is going to provide you with. One is that, as you have seen hinted at in the presentation, you can actually operate over a set of files with patterns. You can also take and create tables that are partitioned based on the data. You can have federated queries that not only query the data inside your Azure Data Lake files and tables, but you can also query against Azure SQL Database, Azure SQL Data Warehouse, and SQL Server instances running inside an Azure VM. We have the standard relational metadata objects such as views, table-valued functions, procedures that allow you to manage your uSQL code and modularize it as well. We also offer you the whole range of SQL windowing functions and expressions, so you can actually not just do data preparation, but also some form of uSQL-based analytics. And we offer you the complex types such as map and arrays, as you have seen part of it during the demonstration as well. I think you agree with me that uSQL gives you an easy way of processing large amounts of data stored inside the Azure Data Lake. It gives you the ability to unify natively the SQL declarativity that gives you the abstraction so that you don't have to care about scaling out and parallelizing, with the ability to extend it with your custom code using C#, and even if you want to, other .NET languages. It gives you a unified way of querying structured and unstructured data. It gives you the ability to query both over local and remote data sources. And it will increase productivity and agility from day one forward for you. So I would like to encourage you to go and get an Azure Data Lake account. Join the public preview at www.azure.com/datalake. And then, once you use it, give us some feedback via our survey or at any of the feedback locations that we are offering you. Additional resources you can find about Azure Data Lake on, of course, Azure Data Lake website. There are several Channel 9 videos that are available that you can follow up in, like diving deeper on some of the aspects. And uSQL resources are both available on the Visual Studio blog site, on 2 entries that are kind of covering into more detail what I was presenting you today, as well as the uSQL reference documentation and the community and team website. You can also reach me at my email alias or our feedback email alias or over Twitter at Mike.bigdata. Here are additional resources that you can follow up on the Connect event and other interesting topics about uSQL, Azure Data Lake, Visual Studio, etc. on Channel 9, MSDN, and other resources. I would like to thank you for your attention, and I hope to see you on the forums and in other places talking SQL and exchanging our experiences on processing big data.